we're wrapping up 3.2 today with synthetic division. Talked about it briefly today in class, but we'll see the actual mechanics of it now. Synthetic division, the keynote here is it only works if the divisor is of the form x plus 2 or x minus 2. If it's not in that form, we cannot use synthetic division, but we can use regular long division of polynomials. Alright, so first example. X squared minus 10x plus 21 divided by an x minus 3. So synthetic division works in this way. We put a positive 3 in here. We put the coefficients that we're dealing with of our polynomial. So we get a coefficient of 1, negative 10, and a positive 21. We'll drop our first term down and then begin multiplying. 3 times 1 is 3. Adding gives a negative 7. 3 times a negative 7 is a negative 21, which gives a 0. Alright? So, these terms right here are the coefficients of our quotient. This last term is always the remainder. So our final answer in this situation would be q of x equals x minus 7 with a remainder of 0. Alright, let's look at another example. 3x to the 4th minus 2x squared plus x minus 5 divided by x plus 2. Well, we're going to put a negative 2 in the box here and put our coefficients up. The key thing to recognize is we start with an x to the 4th, but there is no x cubed term. So we have to account for that. So we get 3, 0, negative 2, 1, and negative 5. Again, drop your first term down and multiply. Negative 2 times 3 is a negative 6. Adding that gives you a negative 6. Negative 2 times negative 6 is a positive 12. This gives you a 10. This gives you a negative 20, which produces a negative 19. And this gives you a positive 38, which produces a positive 33. Again, let me emphasize that these numbers here are the coefficients of your quotient, and this last number is the remainder. So in this situation, our final answer is q of x equals 3x cubed minus 6x squared plus 10x minus 19 with a remainder of 33. So recognize here we start with an x squared. Our solution is 1 degree less. Here we start with an x to the 4th, and our solution begins with 1 degree less. That should always be the case in synthetic division, long division in general. Should be 1 degree less. If for whatever reason you started with an x squared and your quotient begins with an x squared, you've either written something down wrong or you've done something improperly. Alright, so let's look at a few other examples and see where to go from here. So x to the 5th minus x plus 2 divided by x minus 3. We're going to put a positive 3 in the box. Be careful here, we start with an x to the 5th and we drop all the way down to an x to the 1st before we see anything else. So we have to account for all those terms in between. So we start with the first coefficient of 1. We have a 0, a 0, a 0, a negative 1, and a positive 2. We'll drop this first term down. 3 times 1 is 3. We're still adding. Right? 3 times 9 is 27. 3 times 27 is an 81. This produces an 80. And then 3 times 80 is a 240. Which leaves this as a 242. So this is your remainder. So your final answer is x to the 4th plus 3x cubed plus 9x squared plus 27x plus 80 with a remainder of 242. Okay. So as you can see, this is nothing difficult here. It can be tedious. It's easy to make mistakes, just get in a hurry, but it's nothing too difficult. All right. A couple more examples, and then we'll wrap this video up. All right, so if I gave you f of x equals 4x cubed minus 9x squared minus 8x minus 3, and I said show that c equals 3 is a 0 of f. When something's a 0, then that implies that f of 3 equals 0. Remember, graphically, when we talk about a 0, it's the x value where it crosses. So it should produce a y value of 0. So if I plug an x value in, I should get 0. Alright, so what we want to do here is use synthetic division. Your 3 is in the box. You've got a 4, a negative 9, a negative 8, and a negative 3. Drop the first term down and start the whole process. So you get 3 times 12 is 36. Nope, I'm sorry, that's wrong. Drop the 4 down. 3 times 4 is 12. Leaves a positive 3, a 9, a positive 1. If you get a remainder of 0, then we know that c equals 3 is a 0 of f. So that's another way we can use synthetic division, to show that a number is a 0 of a polynomial. Alright, that pretty much sums up synthetic division, guys. We'll work on problems in class tomorrow.